Hello, welcome to my lab 2 where we're going back over the charge tape experiment, but this time with a more complex model of the electric forces. So the purpose of this lab is to compare our point charge model to a line charge model for the tape experiment. In this, we'll divide the tape into delta x segments, treating each as a line charge. We'll just also be using a GlowScript computational code to model all these forces, and the results are that this time we got 2.33 times 10 to the negative 8 coulombs, whereas last time we got 8.86 times 10 to the negative 9 coulombs, so more charge. So the fundamental principles we need to know are the same as for the last time. Gravitational force to calculate how much force is dragging the top tape down, Coulomb's law to figure out how much is pushing up, and then like the charge and the distance, how that relates to how much charge is on each tape, and then Newton's second law in that when the tape is not accelerating, there is no force on it. So here's just a quick overview of Lab 1 results. The top charge was pushed down by gravity equally as it was pushed up by the electric force of the bottom tape. So we decomposed Coulomb's law to find that the tape had a charge of 8.85 times 10 to the negative 9 coulombs. And we did this treating the top and bottom charge as a point charge, as you can see in this photo. So here's our calculation while the tape is at equilibrium. The difference from last time is that when we found the electric force to be equal to the gravitational force, instead of the point charge formula for the electric field, we use the rod formula. And this helps us find a different value of Q because the different charge amount makes a different field. So this just helps us get a more accurate result now that we know how to do this. So here is the model. We pretty much do the same thing where we find the electric field after setting the constants, and then this time we do it for a line charge and then illustrate it here. So as you can see, we pretty much counted each little part of the tape as a rod, and then using that formula made this kind of more interesting diagram. Each green arrow is the field at that point, and then the large arrow is the net field. This is only in the y direction because of the symmetry of it, which makes this convenient. So what are our errors and assumptions? Again, we assume that only gravitational and electrical magnetism act on the system. We also assume that the tape is a lot of line charges. I forgot to update that. Also, errors you could make in the experimental design, where whatever I did, errors I made 3 weeks ago, but loss of charge to surroundings, depending on how quickly you do this, naturally the tape wants to become neutral, so it will get rid of some charge or take on some charge, depending on the environment around it. Also unequal distribution of charge, because we don't know calculus as well. They just give us uniform charge distribution objects and teach us based on that, but in reality that's not the case. So what if the tape was treated as a point charge? So as you can see, those are the results. The calculations are the difference. It's basically just if we treat it as a point charge, it's less accurate. Which one is more accurate? The rod is. It's a better model of the tape in that it's very thin, so it can be thought of as many rods added together. So thank you for watching. I hope you enjoyed making this lab, and I hope we all are successful in our grading of each other's labs.